All right, this is exam 1 for Physics 101, Fall 12. Identify what is the area of this paper in square centimeters. This paper is about 20 by 30 centimeters, about 20 by 30, give or take some centimeters. So 20 times 30, 20 centimeters times 30 centimeters, that's 600 square centimeters. Let's see. Consider this equation. The units for the variables are as follows. T is in seconds, V is meters per second, A is meters per second squared, and X is meters. What must be the units for R if the equation is dimensionally correct? All right, so T is seconds, V is meters per second, equal to R. I don't know the units for R. Meters over A, which is meters per second squared. I can rewrite this taking these things that are in the denominator and flip them up. So I get seconds over meters equals R times meters second squared over meters. So those meters cancel. And I have on the left side seconds squared over meters equals R times second squared. So the only thing I'm missing on the right hand side is 1 over meters. So R has units 1 over meters. Which of these equations is dimensionally correct? All right, let's just take them one at a time. Meters equals meters per second squared times seconds. That's not dimensionally correct. Meters per second squared, meter squared, second squared, and then 1 over V is second over meters. So that gives me a meters in the numerator and a seconds cubed in the numerator. That one's not right. So then I have meters per second equals meters squared over seconds squared. That's velocity squared. And then I'm going to invert both acceleration and time. So 1 over acceleration is seconds squared over meters. And then 1 over time is 1 over seconds. So that gives me, that cancels with that. I have 1 meter in the numerator. The seconds squared cancel. And on the right-hand side, I'm left with meters per second, which is the same as what I have on the left-hand side. So the answer is C for number 3. Given the length of this triangle, answer the next 2 questions. What is the length of the side labeled x? I know that x squared plus 5 squared equals 6 squared. So x squared equals 36 minus 25. Take the square root of both sides. So x is equal to the square root of, what is that, 11? Square root of 11. And that should be, what's the answer? E, I think. Let me just double check. Number 4. Yeah, it's E. It's 3.3. So the answer for number 4 is E. What is the angle theta? All right, well, I have the opposite and the hypotenuse. So what is that? That is the sine of the angle theta equals opposite over hypotenuse. That's 5 over 6. I take the inverse sine of both sides, and I get theta equals the inverse sine of 5 over 6. If you put that in your calculator, you get 56 degrees. So that is B for number 5. Express the result of this operation with appropriate sig figs. All right, I do this operation first, keeping the lowest number of decimal places. That's 38 over 42 plus 4.5. 38 over 42 is 0.90, so 0.90 plus 4.5. Adding that, keeping the, so here I kept 2 significant figures because I was dividing, and these numbers both had 2 sig figs. Now I keep the lowest number of decimal places, which is for this number, so I only have 1 decimal place, which is 5.4. So that's D for number 6. Package is 1.2 by 3.2 by 2.4 feet. What is the volume in cubic centimeters? So first I want to do this product, and I get You get 9.2 cubic feet. All right, and then I want to convert this to meters. In 1 meter, there are 3.3 feet. But notice that it's cubed, so I have to cube this conversion factor. That gets rid of my cubic feet here and here. I'm left with cubic meters. So I need to convert that to cubic centimeters. In 1 meter, there are 100 centimeters. And I need to cube this. This meters cubed cancels out with that meters cubed. And then I do this operation, and I get 2.6 times 10 to the 5th. That's cubic centimeters. Notice I had changed this on the test, so it should have been cubic centimeters, so the answer is C. What are the 3 basic quantities in mechanics? Mass, length, and time. Since 1983, the standard meter has been defined in terms of which of the following. Since 1983, it's the distance that light travels. It used to be a bar, but not since 1983. The current standard is the distance that light travels in that amount of time. Water flows at 45 cubic meters per hour. What's the flow rate in centimeters cubed per second? Let's do the time first. In 1 hour, there are 3,600 seconds. In 1 meter, there are 100 centimeters, but don't forget to cube that term. And if you do that, you get 1.3 times 10 to the 4 cubic centimeters per second, which is D, 13,000. What is the mass of a typical man in kilograms? You know, a kilogram is between 2 and 3 pounds. I think it's 2.2 actually. But let's just say it's between 2 to 3 pounds. That's close enough. Typical man, 180 pounds. All right, that's 70 kilograms. So 70 kilograms is the right answer. So that's between 140 and 210 pounds. All right, taking that. 700 kilograms would be like 1,400 pounds. Okay, so that's not a man that I know. Not typical, at least. Which of these is not a vector quantity? Okay, speed isn't a vector, nor mass is a vector. So 2 and 4, that's A. Consider this plot. What is the direction of the velocity? The velocity of x versus t is the slope. The slope of this graph is always positive. All right, so positive in our cardinal directions. You know, we have north, south, east, and west. So positive is east in our cardinal directions. So that's A. For the motion described in the previous plot, what is the direction of the acceleration? All right, we have a positive velocity, and the speed is slowing. All right, that means that the acceleration has to be opposite the velocity, so it's negative, and negative would be west. So that's B, west. Consider this graph and answer the 4 questions. What is the velocity at t equal 30 seconds? That's right here. We just read it right off the plot. It's 40 meters per second. All right, estimate the distance traveled between 30 and 40 seconds. In order to find that, we have to find this area under this graph. Each block is 10 by 10, so each block is 100 meters. And then we have another little bit left over here. We'll call that 70 meters. You could have picked it out because you already had 400. So it has to be C for 16. What is the instantaneous acceleration at t equal 45? That's going to be the slope at t equal 45. It's going to be right here. The slope of that line. Let's see, I can take a little triangle right there. Let's do it in red so you can see it better. I'll take a triangle right there. You might have gotten a slightly different answer. Let's see, the run is 10. The rise is negative 30. Negative 30 over 10. Oh, let's see, I guess I did a different one. So the answer must be A, negative 4. We'll do this again. So the answer is A. All right, so I'm going to take my line. I think I've done that wrong. Take my line from about here to here. All right, that's finding that at that point. And so my rise here is from 10 to 50, so that's negative 40. My run is 10, and so my slope is negative 40 over 10. Negative 40 over 10. This is just finding the rise over run, which is negative 4. I think that's what I had earlier. I think I just miscalculated what the rise was. All right, but that's correct. Negative 40 over 10, which is negative 4. And now what is the average acceleration for the time interval from t equal 20 to 60 seconds? I'll do it right here. Average acceleration is delta v over delta t. That's vf minus v naught over my change in time. And I'm looking from 20 to 60 seconds. But look, I see that vf equals 10 and v naught also equals 10. My time is not relevant, but my time is 40 seconds, because 620 to 60, but it's 0 over 40, which is 0 meters per second squared. So that's my average acceleration during that time, from 20 to 60 seconds. Which of these velocity versus time graphs represent the motion represented as position versus time graph? All right, so you first want to look at the slope. This, by the way, was the most commonly missed question. The slope here, the slope gives the velocity, and then we have a negative slope. So we have a negative slope of the x versus t, which gives us a negative velocity. All right, this one shows positive velocities, and this one also shows positive velocities. So it's either B or D. Now, the speed is decreasing. Speed is decreasing because if I look at the slope, it's getting shallower. It's getting less and less. So the speed is decreasing. So that leaves only D. Only D for 19. 19 is D. You throw an object upward at a speed of 22 meters per second. How high does it travel? All right, so I'm going to draw a little picture. This was a commonly missed problem, though it was on the homework, almost verbatim. The object starts here and it goes up at the top. It has a final velocity, I'm going to call it v top, equal to 0. And I want to know what is this y distance, all right? So I want to know what is y up here equal to, taking that y naught equals 0. All right, so let's just write down what I know. I know that v naught equals 22. I know that v at the top equals 0. And I know that a minus 9.8. What else do I know? Y naught is 0. I think that's about it. I want to know what is y. All right, so I say y equals v naught t plus 1/2 at squared. But look, I don't know t. So my first step is I need to find t. So I say v equals v naught plus at. And I can solve this for t. I'm going to put in numbers. I know that many of you put in the numbers here. So I'll say 0 is equal to 22 minus 9.8. That's plus a negative 9.8 times t. I subtract 22 from both sides, so I get negative 22 equals negative 9.8 times t. And then I divide by negative 9.8. T is equal to 2.2 seconds. I think that's right, just like 22. Yeah, 2.2, keeping proper sig figs. So t is 2.2 seconds, and then I can plug that in over here. So I have 22 meters per second. It's 2.2 seconds. Plus, I'm going to write it down here, 1/2 of negative 9.8 times 2.2 squared. All right, if I put that in my calculator, I get the answer. It's 24 meters. So C. You throw an object upward at a speed of 22 meters per second. How long does it take to return back to its original position? Well, I know it takes me 2.2 seconds to get from here to here, so it must take twice that to get back. So the answer is D. Drag racer starts their car from rest. It accelerates for a distance of 3.4 meters per second squared for a distance of 400 meters. What is the speed of the race car at the end of the run? V naught equals 0. A equals 3.4. X is 400. And I want to know what is V. I know that V equals V naught plus AT, but I don't know what the time is. So I say X equals V naught T. It's 1/2 AT squared. I know that V naught equals 0. That makes that whole term go away because you're multiplying V naught times T, and since V naught is 0, the whole thing goes away. And so I have 400 equals 1/2 3.4 times T squared. Alright, I divide both sides by 1/2 and 3.4. That gets rid of that. And then I square root both sides. And I solve for T. Let's see what that gives me. I get 1.5 seconds. Alright, now I just plug it in over here. That's 0 plus 3.4. Or excuse me, not 1.5. This should be 15 seconds. 15 seconds. 3.4 meters per second squared times 15 seconds. If I plug that in, I get 51 meters per second. And that's the answer, B. This string of problems was commonly missed, though these were homework problems. So remember when you're studying for the exams to make sure that you're up on the homework, that you really know the homework backwards and forwards, because these were almost identical from the homework. All right, you throw a ball up in the air and it returns to your hand. Which of these plots best describes the motion of the ball from the moment you release it to the moment you catch it? All right, so I have a ball, it goes up, and then it comes back down. As it goes up, the velocity is positive and decreasing. At the top, V equals 0, and as it comes down, you have a negative velocity that's increasing in speed. All right, so initially I have a positive velocity. That gets rid of this because it has a negative velocity, and this one because they both have negative velocities at the very beginning. All right, at the top, it has V equals 0. That's at this point and this point. So A and C are still valid options, but then as it comes down, it has a negative velocity. And this is the only one that has a negative velocity. So that gets rid of this one. And notice it has a negative velocity with increasing speed. So the answer is A for 23. Going a ball straight up, which of these is true? Well, V equals 0, but A is not 0. So it's B for 24. What time is the velocity greatest on this position versus time graph? That's where the slope is greatest. That's going to be C. Where is the velocity negative? That's where the slope is negative, right here. And A. These are the answers. That's the